talk to you about why I personally think that hexagonal and onion architecture are answers to the wrong question, and that begs the question, which question is the right question? Right? So I'm Olli Drotbohm. I've been working on the Spring engineering team for 16 years now. It's my 17th year now. Primarily done Spring data stuff, then moved on into, let's say, more architecturally related work, including the creation of the Spring Monolith project. And when I prepared this talk, I found that the next slide is basically been the key slide for many of my talks in the last couple of years, which is that in technology marketing, and if you look at how frameworks in general are advertised these days, we have a strong focus, or the marketing has a strong focus on this thing here, right? Here is something to create something pretty quickly. I mean, AI-generated applications is just the latest flavor of that. Who of you is fortunate enough to actually be busy in their day-to-day work with that kind of work, creating something for the first time? Lucky you. I mean, Adib, okay, that's fine. I can see that. The mere mortals among us, right? They're busy with keeping the ship afloat, right? We spend time on changing existing applications and actually taking them from version 1.0 to 1.1, what have you. So that's kind of the thing we primarily, because that's where most of the work goes, that's the thing that we need to focus on, to some degree at least. There's a book called Structured Design by Larry Constantine and Edward Jordan. Who has read or heard of the book before? No one. It came across my desk when I was watching a talk by Kent Beck, talking about like the cost of change and the cost of software. And he basically cites a couple of sections from the book. The core thesis of the book here is that the cost of software is the cost of change, which is kind of directly related to what I've just shown you. So the question of that then is like, what's the cost of change? How do you estimate the cost of change? And Jordan and Constantine come to the realization that essentially the amount of coupling in your code base is equivalent to the cost of change. So what does coupling mean in the first place in their definition? I mean, there's metrics around it, but they ultimately define coupling as in a figuratively web of elements in your software system, like classes, functions, what have you, that things are coupled if you need to impose a change on one of these elements, and that requires you to change other related elements of that code base, right? So according to that definition, like these red bubbles here are coupled to each other. And that has an unfortunate side effect, because it's not something that you can decide statically. You cannot say this code is coupled or this code is not coupled, although a lot of metrics actually try to imply that, because the whether code is coupled depends on the actual change that you have to make to the code base. It's most easily understood by thinking of, let's say, your e-commerce application, and one feature request being, we need to add a new form to the customer registration, or a new field to the customer registration form, is one kind of change, and there's a particular elements of your code base that need to be touched to achieve that change. Or there's another requirement coming in saying, we want to exchange our JDBC data access layer with, let's say, MongoDB, right? It's a totally set of related elements that you need to touch to accommodate that change. So if coupling is creating the cost in my software system, so what do? We decouple. Right? So we introduce new elements to our chain of code to be changed, and by that create like more things, or like more elements that we need to keep in our heads, relationships that we have to remember. Yeah, that's kind of we basically add new elements to that chain here. Of course, with the benefit of us allowing to, let's say, change the direction of one of these arrows, like the breaking dependency change, and creating shorter chains, but generally introduce more elements, right? So there's a lot of talk about like coupling and like decoupling elements, and one of the more, let's say, under-discussed terms, I think, in our industry is cohesion. And I'm going to puzzle you a bit probably, because cohesion is coupling. If you think about it, right? So it's the coupling in the places that you want it to be, right? And we're going to see what that actually means in a second. So ultimately, if we're zooming out a bit, I mean, I'm already pretty vague, but zooming out a bit more, the entire act of software design is basically creating elements of strong cohesion that are loosely coupled to each other. So what does it mean to our graph here? So we don't want to deal with this just unorganized mess, but we want to find groupings of these elements that we can basically can surround with some kind of border, and then hopefully we find ourselves in a place that a change actually stays within that. Let me take a step back. We want, but the animation got ahead of me. So, Jesus. So we want to stay here, right? Do we want that change to stay in the element that we actually designed, right? So we want that thing here, because that means that the blue circle is actually forming a cohesive element. So things are coupled to each other, but in a way that we can actually that they support our changes. This is where this slide is supposed to lead to, right? Because we kind of take a bet on what things we have to change in the future, whether it's more of the business people asking us to add new features, or whether it's someone from the technical side of things coming to us asking us to replace our data access layer. And you can probably think for yourselves on your projects what's more likely here. All right. So with that arrangement, let me just take a brief look here. We try to contain the changes in the elements that we design, right? But as of now, these blue circles do not even form a system, because there's no relationships between them, right? And there's this systems theorist, Russell Ackoff. Has anyone heard of Russell Ackoff? Only a few. Just type Russell Ackoff into YouTube, and I bet you have a great evening. Just a giant rabbit hole of great talks. It's basically TED Talks before they even were TED Talks. But he says, and I'm pretty sure you've heard the quote in some form or another, that the system is not the sum of its parts, but the product of their interactions. It's usually the latter part that gets slightly changed, but it's more than the sum of its parts. That's what you hear or have heard probably. So that means we need to actually establish relationships between the elements that we've designed in a way that they can actually, or these relationships actually deliver the value that we want actually to see in our software system, right? So we deliberately have to expose elements from our arrangements and let them act as kind of entry points into our, let's say, modules or logical units in the first place. That's kind of the theoretical fundament for everything we're going to talk about. Because next thing we're going to do is we're going to take a look at separation of concerns architectures, which is the term that I've kind of selected to choose to summarize many of the approaches that you're going to see. So hexagonal architecture or ports and adapters is Coburn. What's the first name? Alistair Coburn. I'm bad with names, I'm sorry about that. Is from 2005, and the idea here being it's basically strategies generally on how to arrange your code in a code base, how to logically assign code bases to architecture elements. He argues that there's an application core, so every bit of business logic has to reside in the application core, and the interaction with the outside world is taking place in so-called adapters, right? So whether it's inbound adapters like an HTTP controller or some message listener or what have you, and there's databases or file system access or any kind of infrastructure connection is happening in there. And the connection or the parts are connected by the application core exposing dedicated ports, right? So it looks like, okay, it looks similar to what we want actually, right? We have these ports, selected elements of our code base that we expose, and then we have implementations that allow us to connect to databases what have you. In 2008, the Onion architecture was coined. It takes a similar but slightly different approach. Again, the domain is at the center of our application, basically domain abstractions, surrounded by application abstractions. There's already like a bit of debate of what goes where, but it's usually the processes that surround the domain elements. And then there's again the infrastructure ring that contains all the elements that we've seen in ports and adapters in the hexagonal architecture. So they look similar. One key difference maybe is that Alistair differentiates between the inbound or driving adapters and the secondary or driven adapters. So they differentiate between stuff that's controllers, so stuff that gets calls, versus stuff that reaches out, right? Which Jeffrey Palermo, I think his name was, didn't really bother to do because to him it was kind of the same. And I've studied these approaches quite a bit, and I was like looking for literature, and you find the book by Alistair, and then it was like, okay, they don't seem very different, but there's so much buzz around it, like what's the point, right? And I was thinking, well, if you think of layered architecture, which is a similar style, we have these like individual blocks here, just calling like something presentation, some UI thing, the business logic piece, and some part in which persistence code lives, right? And the general dependency direction is from top to bottom, right? So, and business logic, depending on persistence, feels a bit like, to everyone working with hexagonal architecture and onion architecture, feels a bit like odd. Interestingly, even the Blue's domain-driven design book by Eric Evans originally describes the layered architecture that way. So in the DDD book, believe it or not, business code depends on persistence code. Something that you would never see somebody doing or promoting DDD these days would even like suggest. And if you look at hexagonal and onion architecture as forms of layered architecture or altered forms of layered architecture, you decide that, well, it's kind of the same with one little detail change. So it's that thing here, we turn that around, and then for hexagonal architecture, we introduce dedicated interfaces in the form of ports on the business logic thing. That's it. Welcome to my TED Talk. Okay? So, and it's been like there's like entire series of books written about this, and I was like, it doesn't feel like there's much in there, or not as much as it warrants a new, let's say, claiming to be a new architecture. Really. Even worse, I guess you all like have seen a Spring application in your careers already. If you had started like Spring when it was coined in 2004, maybe even a bit later, you've probably been exposed to some kind of structure that kind of we promoted for you to organize your code in the first place, right? So if you build a standard web application, then you create some controller classes, there's add controller annotation, and then you dependency inject a service, right? There's debates of whether you use an interface for that or not, and then there's some kind of repository abstraction, originally manually implemented, then along came Spring Data, but it's kind of the structure that you've used when you build Spring applications, no matter what architectural style in the first place. And the great thing is, you've done all three architectural styles at once with this, right? So let's put our layered architecture hat on, then it's this, right? So the controller belongs to the presentation layer, depends on the business layer, depends on the persistence layer. Flip our layered architecture head, put on our hexagonal architecture head. We have our driving adapter, right? Because we're fancy now. And then we just create an interface in the application thing. So we have to like introduce the interface, so that's becoming our port. The repository interface now belongs to the service layer. That's okay, that's that change in arrows that we've seen, right? And then we have our repository implementation being a driven adapter, right? So that's fine. And finally, if we like want to see or interpret this stuff as onion architecture, we kind of have our infrastructure components, controller and repository, and then our application/domain thing. So it's all kind of the same thing, right? Which is fine. It just feels like quite a bit of buzz around something that's. If you can argue like you've done like a hexagonal architecture before it was even invented, right? In 2004. So accepting that it might not be as a fancy thing as it's usually discussed, it's still worth looking at where do these things come from and what do they want to achieve, right? So because that's, especially for hexagonal architecture, you can clearly see, remember it was, what was it, 2008 or something? Let me just briefly jump back, 2005, right? 2005 was the time when we were deploying ear files to web spheres. Is anyone old enough to remember? Oh, poor you, poor me. Right, so when, in a time in which you basically run some code on your machine and it builds for 5 minutes and then you throw it over the fence to some admin and they're running it and it takes another 15 minutes for the thing to even start, to test a piece of functionality that you've just written, then this is kind of the core thing that you want to design your code around, right? That's definitely the case. But at the same time, if you think about the history of Spring Framework, dependency injection in particular, it's always promoted a programming style in which you ended up with code that you could easily unit test in the first place, right? So the way you write code allows you to test the code without all the infrastructure behind it, no matter whether that's a web sphere or whether that's a integration test, which might take some time to bootstrap as well, right? So that's one thing. So we can ask the question of, okay, should we be as focused on the testability thing, or should we be focused on testability in the same way that we were focused on it in 2005? I forgot it already again. So the other thing that is a great thing to pursue is the so-called technology-free domain, right? So proponents argue that you must not use JPA annotations on your domain classes, right? Because then you have tied your code to JPA. Well, what does that even mean, right? I mean, technology-free domain is, if you remember the days when we were using JODA-time because Java was lacking a proper datetime API, is using JODA-time in your domain objects, does that still, or do you consider that still a technology-free domain? I mean, we've decided to encode our domain in Java, so we've already decided for a programming language. It's a slippery slope. That's what I'm arguing. And even with like JPA annotations, these classes are usable without JPA in the first place, even without JPA on the class path in the first place, because missing annotations do not actually cause class loading errors when you use the types as they are. And you could still write unit tests for your JPA annotated entities. I'm not saying that's a good idea in every case. I'm just saying, right, it's not as black as white as you think. And my pet peeve being these architectures being called domain-centric architectures, right? And that usually, or that comes from the fact, of course, that in both hexagonal and onion architecture, the domain is actually at the heart of the diagram that you draw, your visual, your mental picture. Unfortunately, they are as non-domain-centric as they claim to be domain-centric. Because just because the thing is in the middle of your attention, it's also the case for snipers, right, if they shoot you. But the thing is that in the applications that I see, decomposing the domain into individual parts is the primary architecturally driving factor. And none of these architectures leave a word on how you would approach this, right? If you have multiple of these domains, how do you even is it like, do you create multiple hexagonals? Do you create multiple onions? I think the most repeated phrase in Alistair's book is, we don't have an opinion on that. Thanks for being not so helpful, right? So what we're kind of analyzing all of this, I just thought, okay, what about what do you do with onions? Like you cut them, you slice them, right? So I thought, why not just starting, what would the picture look like if we sliced the onion And then it turned out there's these nice little edges on the application ring that are now open to the sides, basically, which allows us to put sliced onions next to sliced onions. And then it kind of reflects the way that at least I think about like Spring applications and structuring them. That fits quite the mental model quite well, because we can then wrap something around that, call that basically our application, and then have our sliced onions as representations of these vertical slices that I want to see in my or that I think of in my logical decomposition idea. And those slices then can expose either domain events. There's something in Spring called the application event bus that you can like publish an event, and then some other slice of onions could actually listen to those, or you could expose Spring beans, which is basically just a reference to some object of some foreign module. And if you think about that, you realize that what's going on within the vertical slices is kind of secondary, right? Because the thing that you need is if you remember the blue circles from the beginning, right? It's these boundaries that expose selected elements to other blue circles. And then what you do on the inside, really, I mean, that's the whole point, right, of a module. You encapsulate decisions. You encapsulate the decision of whether, I mean, you just call a bloody JDBC template from a controller, or whether you integrate with some third-party API and you really want to introduce some abstraction for that. Like the technical complexity is not supposed to drive the entire thing, but the actual business relationships between the individual elements. Right? Keep that in mind. We're going to make this a bit more concrete. Because I've seen, like, I need to go to this immediately. When I usually go to customers and I'm asked to look at their code bases, I can immediately guess what kind of book the architect has read most recently, right? So because it's usually these technical architectures, especially the technical architectures reflected in the code base. So like 15 levels of package or adapter in, adapter out, yada, yada, yada. So you see, when you look at the code base, you see the technical arrangement, even though like I think on the backside of Alistair's book, it's the money quote is, we had so many people that got lost in technical details and they wanted to focus on the domain, and then you open up a code base that's supposed to be written with hexagonal architecture, and all you see is adapters and port and yada, 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 so you don't see anything of the domain in the first place. But, so what's the problem with the technical decomposition strategy being heavily expressed in especially package structures? Let's go into this, right? To make it a bit more practical. Let's start again with our layered architecture. That's like an advanced version of it. We're already like using interfaces for the individual layers, right? That's kind of like, you can argue whether that's needed or not, but let's just stick, for the sake of it, stick with that, right? We have the dependency going down to the abstraction of the interface, and there's an implementation class on the underneath or contained in it, probably hidden by some means. We can go to that. What happens if we put that second sliced thing, so our additional functionality, like we have orders, we want to add like functionality to manage customers next to it. We basically replicate the pattern, right? Because it's foreseeable, it's easy. That's also a reason why developers are usually drawn to these kinds of things, because it's a cookie cutter thing, right? AIs love that, right? You can just replicate the new thing and more code. Wow. The problem with that is, and we even have decoupling going on here, right? So the order service only depends on the repository and whether it's JDBC or not. So decoupling, great. Unfortunately, there's no cohesion anywhere here, right? So none of these service implementations has anything to do with the others, or the order repository implementation doesn't have anything to do with the customer repository. So when we need to change a thing, like a business-driven thing, add a new form field to the customer registration form, we need to touch all of the things, right? So But we're not doing layered architecture, right? We're going to do like, what is it? Hexagonal onion architecture. So we start with that, and what did we wanted to change that one arrow here, no? And this thing in the lower area here. So we move the repository interface to our domain package. So it's becoming a port now, and by that, everything gets better magically. Does it? Nah. We can generate a lot of like similar looking code, that's fine, but still we end up with that low cohesion thing. So it doesn't really help actually, except like we've achieved that we can probably test the domain thing slightly better because of that interface, right? So that's great. So what do we do instead? I mentioned that we that internal structure doesn't really matter. So what if we just started with like a single package in the first place? And then we can actually, use the same approach within that package. So how does that approach make things more modular in the first place? Well, if you look at the first two columns here, in either approach, both or the interfaces always have to be public, right? Because there's a new namespace. If it's, I mentioned in the legend in the beginning of the slides, there was this, it could also be built modules, right? Like say Maven modules or Gradle modules. You have to expose these interfaces to the relatively other concept and to make it accessible, right? For the JDBC order repository to implement the repository, it needs to be public, which means it's also public to everyone else in the system, right? And it doesn't have to be for the single package approach here, right? Because we can just make everything package private, or if you use Spring Modulist, then you could put the code that is supposed to be hidden in sub-packages. Generally speaking, find some way. You could even use JPMS, the Java module system, and then have basically don't export anything. So what does that approach look like if we now add this customer functionality like we did before? I mean, it's still kind of the same. Let's say it's the same complexity. We still create the same structure. We can still use our AI to copy or create the new code. But the only thing that needs to be public is some dedicated interface on the target side, right? So we can, as I described in that theoretic part before, we actually designate the customer service interface to become one of the blue bubbles on that on the blue rings, right? So we dedicatedly design our modules, our code structure, with regards to what we expose to others, and we can still hide everything else internally, right? So we basically, in this case, like we could argue that our controller and repository are part. That could be again interpreted as onion architecture, but essentially, as I said, it doesn't really matter, which means that we could also, for let's say an additional domain that doesn't require that complexity, that abstraction, guess what? And don't tell anyone, I'm glad it's not recorded, we can have our controller inject the bloody JDBC template and then just call select from yada 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 yada. If that does the trick, right? Because nobody else is affected by that, and we can, let's say, for some reason we get a new requirement and things become more complex, we can introduce that indirection, that technical decomposition approach later when we need it, right? That's the idea. All right. So you hopefully saw this kind of schematic thing here reflected in the package structure, and we actually hopefully get to a point. So that's kind of the design goal for us, to come up with these blue circles that allow us to actually contain the changes that we need to our system, or as many changes as possible. It's never going to be like only these kinds of changes versus the other kinds of changes in our system. Right? So this is this slightly more advanced, let's say, more elaborate description of what I hopefully got across here, right? We need to find a decomposition strategy that supports the changes that we need to make. And yeah, to summarize what I've just been talking about, basically, is yeah, I hope that got across, right? The interesting observation I think I made is that when you design for cohesion, so you try to build cohesive elements, you automatically get to decoupled elements because it just naturally falls into place. I've seen tons of teams being focused on trying to decouple things from that, build hexagonal architectures around, because like the repository interfaces with the help of Spring Data, they, in their minds, become, oh, these are Spring Data repository interfaces, right? So they're technology dependent. And to get to a technology-free domain, we need to have a repository port on our application core, and then have an implementation that then delegates to the Spring Data JPA interface, which is kind of like, I mean, really getting weird, right? So we want to get to these circles. Functional decomposition over technical decomposition. I guess I got that. And that's kind of what I wanted to get across with the title. It's not that technical decomposition doesn't have any value at all. It's quite the opposite. It's just that I see so many teams being like, we build our application as a hexagonal architecture application. That's kind of a non-starter. It's basically saying, oh, we build our application with JDBC. So it's one aspect of the thing, but it's completely missing like all the other things that you need and that are especially important in your overall architectural approach, right? Especially because, I mean, in the examples, to keep them simple, I usually talk about a single system composed into individual elements, but that's usually not the way it is in your real-life applications. You probably know that. I've never seen a monolith, like a system that doesn't talk to any other system in a company, right? So even if you build a rather monolithic system, there's usually that other thing that you need to notify, or some message that you need to send to, or call some other third-party service, what have you. Very important, the intrinsic complexity of the vertical slice defines how much accidental complexity you have to apply, right? If you find subdomains or vertical slices that are very simply structured, they are just like, we just need to read some data from the database, turn it into JSON, and provide that as some API or to my other modules. There's no need for an elaborate adapter for yada yada yada. Just start simple. That's what I'm trying to get across, like this here, right? And the other thing being, and it's also coming from that kind of arrangement, or that train of thought here, is that we need to make sure that we use the elements that we have gotten from our language that are supposed to provide means of encapsulation, to actually use them as means of encapsulation and not only as means of organization. I'm going to get back to that in a second with some kind of example, right? So it's kind of this thing here, right? I see people create packages to, all my controllers go here, and all my exceptions go here, and all my repositories go here, which is understandable because, or the analogy I usually use for that is that it's like if you, at home in your flat, you were putting all of the chairs in one room and all of the tables in another, and all of the closets and wardrobes in a third room, which is incredibly convenient if you spend your entire day answering the door because one of your neighbors comes like, can I borrow a chair? And then I need to go into this room to grab one. But it's incredibly inconvenient if you want to have friends around and dinner with them, right? Because right, you need to bring these things together to perform, as Eckhoff said, to make the connections and then actually have a higher value than just a chair and a table, like pieces of wood, basically, combined. So there's one more thing, and I briefly hinted at that in the keynote. There is this, how do I start this? The way we talked about architectural elements here in the form of adapters or layers or onions. It's kind of, they all serve one purpose, is to build our mental models, or the mental models about our code base. The way we think about our code base, the way we think about our software design is shaped by these approaches, right? That's why they exist. And they exist because they allow us to reduce the complexity, or be as abstract as possible, but as concrete as needed. When we all have a shared understanding of hexagonal architecture, I can say adapter, and everyone in the room knows what I mean, and actually knows about the traits of the thing that I'm talking about. Right? It's things that are allowed to connect to a certain technology. They are not allowed to reference the domain in particular, what have you. So we use these abstractions and pattern languages to build and shape our mental models, our understanding of the piece of software that we work on. And then we go back to our computers, open up our IDEs, and get presented with source, main, Java, right? Folder structures that are kind of, like, it's folder structures essentially, and there's a thin layer of, where do I need to go? Here, and then slide over here. There's a very thin layer of abstraction over the actual file system, right? Because in this case it's VS Code, it knows, let me scale that up a bit, it knows about the notion of a source folder, right? It basically knows the Maven or the build system abstractions, and it groups them accordingly. It then knows that everything underneath that is a package, so it doesn't present us with like folders to navigate, but like a combined thing of, I don't know, the packages. But that's a very, like, again, technology-centric abstraction. It's totally not on the level of abstraction that these architectural pattern languages talk about, right? They talk about adapters and ports and aggregates and what have you. And there is this other side project that I'm a bit involved with called JMolecules, which intends to allow you to express these stereotypes in architectural and design elements in your code base. So that if you navigate to, for example, you have this order thing here, and there's an order type. There is a type-based, basically, pattern language called the aggregate root. Is there a hover here? See, there's org JMolecules DDD types. So there's basically a set of jar files in which you can that contains jars types that you can then use to basically assign these roles, similar to what Spring does with add controller and add service, to these elements in your code base. And I've worked with the tools team, the Spring tools team, to actually bring that abstraction to your IDE, right? So that you actually can go ahead. You see that in the lower left here already. So the IDE recognizes this is a Spring Modulith project in this case. So it uses all the structural information in the code base to present like the logical modules in here. If you created a new package, basically in parallel to order, that would automatically create a node here, right? And there is it automatically analyzes which of the JMolecules libraries you use on the class path, and groups your coding elements according to the stereotypes, so that you don't have to create packages named repository, named configuration, named what have you. Right? So you probably see this here there's the initializer, there's a projection in order. This is basically Spring Data projections. You find that down here, right? And there's, again, you might not realize, but again, it's functional decomposition first, functional groupings, and then everything else like the design languages like domain-driven design, or technical stuff like Spring configuration classes is here as well. And guess what? There's a branch of this project in which I decided to go ahead and say, I want to use hexagonal architecture as the technical decomposition approach, which means that I actually say that my payment web, there we go, my payment controller is a primary adapter. You could argue, like, why would I have to do that in explicitly? Because we could, like, kind of derive that a controller is an adapter, just as I presented before. But let's stick with the idea of we make this explicit now. Then there is if you just enable the hexagonal architecture stuff here, you basically get this thing turned into, I'm not sure it's readable in the back here. Let me zoom this up a bit. Right? You get these abstractions, these architecture specific abstractions folded into the tree. So they essentially form a sub-level of grouping here. So you can see, okay, all the primary adapters consist, here's some request mappings, here's some controllers, and there's something coming from Spring HTOS, like representation model processes, whatever that is, right? An abstraction that's specific to the web layer in this case, right? And this is not only for predefined annotations. You can go ahead, and I think I've done that here. That's been like a slightly more advanced step of the exercise is that we created, wait a second, nope. I think it's here, right? So what I did here is I created an interface called DTO, because in this particular project, a DTO is a concept, is a thing that I exchange about with my team. We all know what it means, we know what characteristics are, stick with it, and you probably have these things in your applications as well. Things that have not made it into books because someone wrote about them, but they are kind of, maybe not domain specific, but company specific. You could just create these abstractions, annotate them with add stereotype, and there should be a primary adapter. There's not, why is there not? Let me just get this out of the way. There should actually be, there is a payment form thing going on. It's hard to navigate this way. Sorry about that. But payment form, I clicked it. In the payment controller, boy. Oh boy. I love it when the shortcuts don't work. There should be a payment form implements DTO, and that should actually show up in the payment slice down here. Does it do? Yeah, it does. The pluralization is a bit broken. It should not be DTOs, but you see that just because you added the stereotype into your project, you add the annotation to it, there's some annotation processor running, and then the IDE automatically picks that up. So you don't need to ask or wait for the tools team to integrate with your abstractions, but you can actually introduce these abstractions in a way that the IDE will pick them up and present them to you, and allow them both to think and navigate the code base in those terms. All right, available in everything that's Spring Tool Suite based, so VS Code and Eclipse. I've been just talking to the guys over there. There's going to be something for IntelliJ as well. All right, that's actually all I have for now. So we have like 5 minutes for questions. Thank you very much. Any questions? If you're too shy, I'm the short guy with the hat. I'm easily discoverable, despite my lack of height. Excuse me? Oh, there are some in the app. That's a good one. Good point. Yeah, please leave feedback. If you liked stuff, if you didn't like stuff, that's fine. I love feedback. Where do I find the stuff? Agenda, domain-centric. There's a couple of likes. There's 4 questions. Oh boy. How do you see modules relating to bounded contexts? My take is that ideally they overlap, but there are reasons why they should not. If you follow the domain-driven design school, then a bounded context consists of one or more modules. So if modules are a means to subdivide bounded contexts into different, like, again, functional parts. What's associated with the bounded context is usually a bit of like technical work in terms of like anti-corruption layers and being defensive about what you hand in or hand out. So It's not a bad idea to start with a one-to-one mapping, but you don't necessarily need to be as strict in terms of like being defensive, receiving data or what have you. Would you share models across the module boundaries? Why or why not? I would try to avoid that as much as possible, accepting that it's not always possible, right? So try to, these kind of core packages, they always exist, or util things. I usually rename them to kitchen sink, and then people are less likely to put stuff in there. When to use monolith and when separate microservices? Hard question. I would definitely need to take a look at the circumstances of the project. There's two main drivers. One is like technical aspects like scalability, although you can achieve a couple of things even within a monolith with terms of caching. The scalability, if you need to use other programming language platforms, like, I don't know, there's a special thing that's only available in Go, then of course you need to build that as a separate application. The other thing, a non-technical thing, is organization. So Conway's law applies if you have a lot of teams that need to work on the same code base. That still works on a well-structured monolith, so you can still do that. And I hope this morning in the keynote I made a case for these teams even being able to roll out changes quickly, but it totally makes sense to look into, does it maybe build a separate application just to give them their own space. On the other hand, I always get a bit like weird, or I'm a bit concerned if I see a team managing 15 different applications that are actually logically one, right? That's what I would or is at least a smell. Models, yes. Do you have any tips or suggestions for adopting a monolith architecture? I'm currently using a Gradle multi-module setup to separate responsibilities. First thing is you apparently are aware of the problem. You found a means to actually solve your problem, and if in doubt, I would stick to that, right? So don't change things for the sake of changing things. Sometimes it's possible to get rid of a couple of these, especially if I've just been with a customer. They had like an OSGI-based application from the ancient past, 500 OSGI bundles, and from these 500 OSGI bundles, they composed 3 different kinds of applications, like a core application and then these kinds of satellite things. And we actually reduced them to exactly these 3 kinds of, not 3, or it was 4 or 5 actual applications, because they didn't need the composition in that fine-grained way, right? Whenever you produce artifacts, it also means that you expose the decomposition to external parties, which might not be a problem in itself, but if they then have to reassemble these things, it might just be more complicated. It's actually also a balancing act for us in the Spring framework, right? So it would be easier to consume Spring if it was just one jar, right? But at the same time, you would not want to deploy like, I don't know, 15 megabytes of code that's not needed. So there is this balancing act between the amount of artifacts that you produce and the size of the artifacts. And if in doubt, stick with the modules, with the build modules, and you can still use Spring Monolith for integration testing, for generating documentation. That would still work, right? Even with if you use like something like JPMS for the actual low-level module system. What are your thoughts on a BFF? I think that's backend for frontend module. I often find that end user needs aggregated data from multiple modules. Yeah, so that's kind of the that's actually a hill I'm willing to die on, is that I think that this split of front-end application and back-end applications is the weirdest thing that, I'm not sure who came up with that, but I guess developer or technological operation or technology companies are centered around these, like, we do Java and we do JavaScript, and that's why we form separate tribes and we don't want to talk to each other. And I think most teams would be better off if there was no such split. Because if you think about it, if you have a front-end team and a back-end team, none of the two teams can actually ship a feature in the form that it's valuable to a customer. The front-end team cannot because it has to wait for the back-end team. If the back-end team ships stuff and there's no front-end for it, no customer is actually going to use it, right? So it feels like a continuation and an extension of the kind of horizontal split thing. So I would want to avoid that. It doesn't mean that we shouldn't have like experts on the particular technologies in the teams, but if in doubt, I'd probably start from that assumption. And there's probably valid reasons in many cases for that split then to happen still, but you've got to be aware of the downsides that brings, right? How much time? I'm over time. We had that already. That's a bit of a complicated one. It also needs a more unweighted answer. I'll be around all day today. Tomorrow, catch me if you can. It's fine. Thank you very much. Thank you for your time.